In this video, we're going to cover section 2.5 on functional groups. Now, a functional group is a characteristic group of atoms and bonds that possesses a predictable chemical behavior. Now, the chemistry of every organic compound, regardless of its size or complexity, is determined by the functional groups present in the compound. And we use functional groups as a way to classify organic compounds. So for example, in the hydrogenation of an alkene, the term alkene is used to represent this type of structure where we have this pi bond found within the carbon backbone. So when this functionality, this alkenyl structure, undergoes a reaction in the presence of hydrogen gas in the presence of a catalyst platinum, the resulting structure, as you can see, the disappearance of that double bond to give us a sigma bond, the alkane that's formed is yet another type of functionality. So many of the reactions that we'll look at in this course are really about functional group transformations, going from one functional group, one family of compounds, to another family of compounds. Now, the next two slides are tables that identify the various functional groups that we commonly observe in organic chem. And we won't look at in detail all of these functional groups, but we'll look at a number of them. So for example, alkyl halides is a way in which we classify the functional group, which is a R group, which can represent any kind of carbon-based system, some hydrocarbon, attached to a halogen, which is often given the symbol X. So that halogen could be a chlorine atom, a bromine atom, or iodine, for example. So when we see a carbon backbone and a substituent or a group such as the halogen attached to it, we would classify that compound as an alkyl halide. And here's a typical example of 1-chloropropane. As we saw in the previous example, if we have a structure that contains a pi system, as that in a double bond, we refer to that as an alkene. If there are two pi bonds present, then we refer to this as the alkyne. Alcohol, the alcohol functional group, is a structure which contains a OH group, which is known as the hydroxyl group. So when you have a carbon backbone attached to this OH group, we refer to that compound as being an alcohol, or at least that region of a more complex molecule is having the properties of an alcohol. We have ethers, those are common solvents. That's where we have an R group on either side of a single oxygen atom. Thiols and sulfides are the sulfur-containing compounds. We won't spend a lot of time looking at their chemistry, but some thiols will be discussed in terms of their ability as reagents or reactants with other functional groups. The aromatic compounds, benzene being its primary member, or what's also referred to as the arene family, refers to ring systems that have this conjugated pattern of double, single, double, single, double, single bonds. We'll look at the naming of these compounds, but we won't spend a lot of time on their chemistry. In the second part of this table, we have examples of common functional groups, which for the most part contains the carbonyl. So we have various structures that contain this carbon double bond oxygen, and it really depends on what's neighboring the carbon of that carbonyl group as to what functionality or functional group it belongs to. So if we have two alkyl or hydrocarbon groups attached to the carbon of the carbonyl, we refer to these as ketones. If one of those groups is carbon-based, but the other is a single hydrogen. This is the aldehyde family. You can see a four-membered system here, the butanal. If you have an R group to one side, but an OH group to the opposite side that's directly bound to that carbon of the carbonyl, that belongs to the carboxylic acid family. Acyl halides, if that group is now a halogen. Now, if that group is a oxygen attached to yet another carbonyl, we refer to this family as the anhydrides. If we have an OR group, so an oxygen directly attached to the carbonyl, but then some other alkyl group attached to that, we refer to this as the esters. If it's a nitrogen center, whether it's substituted with hydrogens or other R groups, we refer to these as the amides. And the amines, where you have a nitrogen center, which is directly attached to multiple R groups, the simplest member being NH3, ammonia, but as we substitute with various R groups, we have our amines. So again, this table summarizes examples of common functional groups. And this classification system allows us to organize organic molecules into groups which are named in a similar way, generally have similar properties, and also react in a similar fashion in the presence of reagents. If you have any questions about functional groups, by all means, send me an email or start a discussion in our forum. Thank you.